Okay. Hey. Hello, everyone. I'm José Simões, and first I would like to thank David and Darren for in behalf of the project, and myself, of course, for the invitation and for the opportunity of being here and present you this nice framework. Okay, so I'll go ahead and start the presentation that I have here. I'll be watching the chat. So if you have any questions, please go ahead and interrupt me at any time, and I'll try to answer those. Okay. Very well. So .NET Nano Framework, what this is all about. Um, this is um, this is basically a shrunk .NET CLR, which is made to be small and efficient in order to be able to run on constrained embedded devices. And when I say constrained, is really constrained in tiny devices, it's even smaller than the Raspberry Pi, which is probably the ones that. And if you're doing IoT on C Sharp, which is used to use. So it enables you to write C Sharp code for small microcontrollers. Um, Obviously, it doesn't have all the features and the API of the full .NET framework. It wouldn't fit in there. So we have a subset of the .NET API that you are used to. Pretty much everything that it's required for basic and not so basic application you find there. You have the namespaces for threading, collections, math, string manipulation, even complicated stuff like regular expressions. You'll find there. Just like the usual stuff that you find on IoT, like GPIOs, SPI, I2C, networking, and all that stuff. Um, because it's .NET, it supports natively multi-threading without any special library or doing anything. You get the same behavior that you have on with a full framework, which is you basically start your threads and the execution engine makes sure that they all run. They have their slice of time to run and switch between them. And when a thread is ready to run, it will do that on a round robin fashion, like it happens on the full framework. It also has support for interrupt code, meaning that you can use C and C++ code and call it from your C Sharp application, which is very cool and quite handy if, for example, you are doing something that is time critical and you don't want that to be interrupted by the thread switching. You can do that on the native code and still access through an interface the code that you have there. This is even interesting to be able to reuse drivers and C code that you have maybe for other platforms that you want to use here. That's possible too. Um, Next, regarding the general API, this started as the UWP API because back then when we started the project was the only decent IoT API on the .NET ecosystem. That's the reason why we picked that one. Right now, with UWP being discontinued, we are working to port all the APIs and to align them with the .NET Core IoT, meaning that you'll find the same API on, for example, we have already done the GPIO and the I2C. SPI is next, and you find the same API on the .NET Core IT and on the .NET Nano framework. So the Nano framework is capable of running on any 32-bit core. Actually, this is the minimum. You could possibly run it on an 8-bit, but that would require more work and being able to to deal with the data differently. So 32 bits is it's the recommended minimum. But of course, you can run this on any 64 or even Pentium if you have one on the attic. You can run on a framework there. There is no port for that, of course, but it's perfectly doable and makes it very flexible because of that. Um, we basically have this organized in a way that we need two threads on any RTOS that runs on so basically the Nano framework runs on top of that. One is runs the CLR and the execution engine, and the second one runs the communication component, which is responsible for the interface between Visual Studio or any other tool that you have out there, and being able to communicate with a microcontroller for the deployment to run a debug session on Visual Studio and all that. So, what the not the .NET Nano framework is not. This is not an RTOS, but runs on top of one. Like I said before, we basically need two threads to run the execution engine and the communication component, and that's it. Um, it does not have a JIT, and it's not capable of using standard .NET assemblies for a very simple reason. Any regular .NET assembly can easily reach some megas in size, and you can possibly fit that into a microcontroller. That's the reason why we have that's the reason why we can't run the .NET assemblies, the standard ones. What happens is after the regular build, because the build runs is performed by Roslyn just like any other C# application, and after Roslyn does its thing, we have an extra pass on a tool that we have specific for the Nano framework, which parses the DLL or the executable, and strips out anything that's not required there. So it can be made as small as possible to be able to fit in the microcontroller flash. Um, and to be able to be run there. Mike is asking if you can run the .NET Core IoT device bindings. Um, that's a work in progress. We have about one third of them already ported, and the remaining ones are a work in progress. So far, we estimate that we can cover about two-thirds of the bindings that exist today on the .NET Core IoT. The other third will be tricky to implement or require a bit more work, but it's already a nice number, two-thirds of those. So that should be available shortly. Okay, a bit of history about the nano framework. This all started back in 2016 August, when we tried to revive the .NET micro framework. And failing to do that, decided to take this into our hands, and me and a couple of other mates decided to spin off the project, because it was really a shame if all this would be lost, because this is absolutely incredible, what you can do with this, and the fact that you can run .NET on and C# code on a microcontroller. It's simply amazing, and that's why we decided to spin off the micro framework. We basically strip it out of anything and everything that wasn't useful. We changed completely we rewrote completely the build system, the wire protocol, which is the part responsible for the communication with the Visual Studio. And we made that the CLR and the execution engine completely independent of the RTOS, which is something that didn't happen on the micro framework. All the parts were tangled with the networking and the drivers and all that. So we took care of that, so that right now all that is completely independent and can be and can run on top of any RTOS that you find there. So all this happened pretty quickly, and we were able to make the public announcement of the framework in January 2017. Um, Sometime after, with almost a year, we got the debugging part fully functional on Visual Studio, um, and then on 2018 September, all this progress, all the libraries, for the drivers, and the networking, which was something that we wanted to be available when we had our first release launched. And we managed that on September 2018, and networking with TLS capabilities included. And networking means Wi-Fi and Ethernet, so wired and wireless cable. So all this keeps moving forward, and in 2019 we added support for Visual Studio 2019. On June, we were aware of the first commercial product running .NET Nano Framework. Um, on September last year, another major milestone, which was the project joining the .NET Foundation, um, which was pretty cool, because we with that We are part of the officially part of the .NET ecosystem, and that's been very helpful on a bunch of stuff that we had kind of stuck. And right now we have a better access to Microsoft and the development teams there, which will help us to move forward more quickly. Last milestone worth noting is last February we announced the unit test framework, which is something also very important for anyone concerned with quality in code. So right now, the unit test that you know from .NET and Visual Studio is available, and you can use it and run unit tests on your projects there. David is asking about the how much RAM requires the nanoFramework to run. It's not much. I'll have that on covered on a couple of slides ahead. Okay. So this is the .NET ecosystem on which we are part of it now. And as you probably know, .NET Nano Framework is an open source project, and this is 100% open source, meaning that from the firmware that you have, the running on the microcontrollers, to all the class libraries, the Visual Studio extension, the CLI tools that we have, and also the scripts that we use on our build pipelines are all available on our GitHub. So it's free for anyone to go and look and search and do whatever it pleases with it. So right now, and some numbers to give you an idea, we have 66 NuGet packages. We have more than 760 NuGet package downloads. I just run this number today, and we have over 11K downloads on the Visual Studio extension. This count is for both the both versions, the one for the 2017 and 2019 versions. Okay. Some more numbers regarding about the project. We are of course on GitHub. We have 72. We have 79 repositories, but only 52 of them are for libraries and code that we use. All the rest is for SDKs and the RTOSes that we use, which we have focused on our GitHub organization. So far, more than 60 people have contributed with code. This is the total for all the repos that we have. We have a total of 480 forks and over 1K of staff. Okay, so a bit on the .NET Nano Framework architecture. This is you can see here on this layered approach. We have we have at the top the user code, and this would be the user application and libraries. Just below that, we have the base class library, which includes the system libraries, the .NET, the .NET namespaces, the hardware, network, UI, and some other high level stuff. Then keep going to the lower part, to the hardware. We have then the CLR, which includes all the basic stuff that you also find on the full .NET, the big brother. Have the execution engine, the garbage collector, all the type system, and the built-in functions to make sure that everything runs smoothly there. And then, of course, you have just like any other embedded system. You have the PAL and the HAL, which are responsible to abstract the hardware from the higher levels. Um, and there you can find the networking, timers, watchdogs, events, RTC, the access to the microcontroller peripherals for the various protocols and peripherals like the CRC calculators, the UARTs, the SPI, I2C, all that stuff that you can find there. Um, on the right hand side, you can see the languages that are used for the various layers. On top, of course, you have C sharp, and then you'll notice that the user code and half the system libraries are C sharp, and the other half is C and C++, and some of them have a tiny bit of assembly too. So this is the distribution in terms of languages. Okay. Right now on the supported platforms, like I've said before, this is capable of running on any 32-bit core or better, like most of the ARM Cortex M's, or even the Tensilica Extensa, which is better known as the ESP32. Like I said, these two are the ones that we have ready to flash images on our GitHub repository. But because of those abstractions and the way that we have it designed, it's pretty straightforward to add new CPUs and new RTOS there. So it's relatively easy to do that. And now I'll give to answer David's question about how many RAM. In order to have an usable device, something around these numbers that are here, 128 Ks of flash and around 62 of RAM. It's the I would say the recommended amount of flash and RAM that you need. We have this run on devices with less flash and less RAM. But the thing is that despite you can load the libraries there, it doesn't leave you much room for the user application. So unless you want to make something very small with very few functionalities, it's not interesting to use something a device with less than these numbers here. All right. Regarding the RTOS that we have currently running on the various devices, we have Chibi OS, we have FreeRTOS, and this one goes to including the variation for the ESP32, because they run their own customized version of FreeRTOS. And the FreeRTOS is also the one that it's being used on the NXP reference target that we have. Then we have also the TI RTOS which is runs obviously on the TI devices that we have. Um, and last but not least, the Azure RTOS. This is a somewhat work in progress, which is not far from being released. The first device running Azure RTOS, which will be an STM 32L4 device, one of the boards that is used as a reference on the Azure RTOS. That will be the first one running it. Like I said, it's the way that it's designed. It's very straightforward to port it to any RTOS, because basically what we need from the RTOS um, is what you find on any of them. Basically, thread switching, thread intercommunication, either with messages, queues, semaphores, mutexes, and all that stuff. So it's nothing complicated, only the basic stuff. So it's pretty straightforward to port this to another RTOS, which is not listed here. Okay, now speaking of some of the reference targets that we have, here is worth noting what I'm calling reference target. Reference target is the name that we come up to designate the boards that we have there, and that can be used as reference if you want to design something, a system around this, and using nanoFramework. So we try to choose there different targets from the various vendors, and different Cortex M's and the ASP, so that you can find one that is close to what you are looking for, and then take it from there. On the From the ST microelectronics is the ones that we have more targets. We have from various years, from the F0, the F4, the F7, and the last two ones that are here, the L4 and the H7, are the ones that are coming with the Azure RTOS. Right now, with ready to flash images, we only have for the first three series that you find there. And with this, the F0 will be the smallest one, on which you can find those 128 case for the flash, and 64 case for the RAM, and the F7 would be the most powerful one, on which the more beefy device that we have there. It's I think it's 2 megas of flash, and probably 500 Ks of RAM, internal RAM, because it has external RAM, which amounts to something like I think it's 8 megabytes. So it's a lot of RAM. So you can create a lot of objects on your C# application, and even run the UI components there, and that should be more than enough to tackle any more complicated project that you have there. Okay, next group, and this is a very popular and populated one, are the ESP 32 devices. Um, we have also ready to flash images for any of these devices that you see here. The mainstream ones, like the dev kit or the rover kit, and also the LilyGo, and a similar one, which is the Olimex, which include the Ethernet um, too, besides the ESP. And also for the M5 stack devices, both the core and the atom. So for all of those, um, you can find a ready to flash image on our GitHub repos. Okay, next one we have the TI devices. Um, the series that we have as reference targets have a design architecture very common, and they are very interesting because they all have dual cores, Cortex M's, um, one that is more powerful and runs the user application, and the second one, which is responsible for running everything with the radio stack, meaning that the protocols are there, and also all the tasks and threads to interact with the radio stack are run there, and also the radio part and all the surrounding components are also included on the chip, um, which makes it possible to have a complete running system with basically the microcontroller, a couple of capacitors, and just the antenna and the feeding circuit, which makes this very interesting. The CC3220, it's a Wi-Fi device. It runs Wi-Fi, of course. It's very similar in features with the ESP32. It includes a secure bootloader, and uh, has a lot of flash and RAM to run any application that you want to run it there. The second one, the 1352R, it's a very neat device. It also has a dual core and the radio on the same chip. Um, and on the boards, don't be mistaken. The chips that I'm talking about are not the large ones on the top, are the small ones on the lower half. So they have some KFPN packages, very small. Um, as I was saying, the 1352 is a very interesting device because with just changing the antenna and the feeding circuit, the radio is software programmable, meaning that you can run the sub gigahertz frequency there, and also 2.4. Um, and it's out of the box. It's able to work with wireless M bus, 6LoWPAN, Bluetooth 5.2, Zigbee, IoT, Thread, and even proprietary protocols that you want to throw in there. So it's a very powerful device, and incredibly flexible on what you can do with it. All right. Next one on the family is the NXP, and this is also a Cortex M, and this evaluation kit that you see here. It's also a very interesting device, which includes external RAM, the Ethernet connection, SD card, and all that stuff that you can find on um, on a board ready to be used on serious projects. Okay. This is the one that runs the free RTOS. Last round on the reference targets. We also have images for the net Duino 3. Despite being already discontinued, there are a bunch of units out there, and this is one of the popular ones that came from the micro framework world, and we wanted to also give some support to folks that have this board. So we have an image for NetDuino 3. Unfortunately, it does not include the Wi-Fi networking part, but nevertheless, it's still a great board to play with. And then we have the ArcPal 3, which is from a company, an US company called ArcPal, and this is used on their telemetry system. This was the first commercial product that we were aware that runs .NET nanoFramework. Right now, it's being used on their telemetry system, like I was saying, and it's deployed on several locations, doing oil field monitoring on the tanks. If you want to read more about this, you can find information on our website with the documentation, on which you can find the case study describing all this and how this is being used. The One of the ones that has more units deployed is running on a battery and a solar panel. It's has instrumentation on the tank, and communicates with the cloud through a satellite link. So basically, sleeps most of the time, and wakes up periodically to do the measurements, and sends them over the satellite link, and it's a very interesting use case there. Okay, so, and this addressed some of the another question that was on the chat. Um, Regarding targets, these three here are work in progress. The ST1 I already mentioned before. It's one of the boards that is used on Azure Autos as a demo system. It includes an STM32 L4 and a Wi-Fi module and a bunch of sensors that are available on the board around the MCU. The next one, it's a Maxim device, Maxim microcontroller. It's brand new one. It's the Max 7H1000, and it's also a dual core, on which the second core is optimized to run AI models. So it's the idea that will be this will be the first device that we have targeting specifically this segment of AI, which is something that is quite interesting these days. And finally, we have the Raspberry Pi, the Pico, on which we have already some work done. We are kind of coordinating this with the Azure RTOS team, so that they can have a port running for the Pico. As soon as we have that, we'll be able to run the .NET nanoFramework on it. We have some blinking LEDs right now, but it's not ready for prime time yet. All right, on the SAMD, we don't have any port for SAMDs, David. So unless that there's a compelling case of someone wanting to work on the port, we don't have one, and we don't have that on our roadmap. Okay, .NET Nano Framework could be our platform for building almost anything. So as long as you have enough flash and RAM to code whatever the application that you want, you can do that with Nano Framework. Depending on what you need. If you need connection to the web or to the cloud, um, we have libraries for that, and you can do that. Wireless connection for interacting with a mobile device too. IoT too is IoT sensor devices, edge devices. That's the bread and butter there. And also AI, if you want to run an AI model there and do stuff with it, it's also possible. We have on our roadmap to integrate. We are looking into integrating the machine learning .NET, and also some with TensorFlow and other stuff that will come along with the Max device that I mentioned a while ago. You can code for that using Visual Studio, of course. Visual Studio Code is here because of the native part. Despite you can also code for the native part with Visual Studio. Most people prefer to use Visual Studio Code, but both should work for that task. And then the command line, because you have we have CLI tools to, for example, the most basic stuff, like if you want to update your devices and the firmware, we have the nano firmware flasher. That is a .NET Core tool, on which basically you just plug in the USB cable to your device. You throw in some commands, and it will grab the image from our repositories and will flash the devices that you have there. You can even use it to in production because it's easy to do, being a command line interface. You can even automate that, and you can use it to flash the application there too, in even a full image on which you can have, for example, some test application that you run on the production line before you ship it, and that's available too. Um, Okay, ready to use libraries. All the libraries that we have are conveniently available and distributed through NuGet as NuGet packages, of course. And being C Sharp and using the same .NET API that you are used to, it's very easy to find code samples on the web, to ask questions about it on Stack Overflow, and going through the samples that you find on GitHub and Microsoft websites. So it's pretty easy to do. And being C Sharp, it's very easy to extend and to make it work for what you need there. Plus, being open source, you can always look at the code for the various libraries, and if you are stuck on something or you think you find a bug, you can go and look at the code and even why not submit a pull request with an improvement or a bug fix? So it's there for exactly that. We have libraries, all those 66 libraries, like I mentioned before, cover the usual stuff that you find and that you need on embedded systems, like the GPIO, SPI, watts, whatever. Networking components are there. You have the system.net API there, where you find the sockets, the UDP, the TCP, and all that stuff. We have also a very good subset of the HTTP namespace. You'll find there the HTTP web requests, web responses, and all that stuff. We even have a library with a web server, and the sample runs on both ST and the ESP32. So out of the box, you can have um, in a very short time a project, for example, with a device acting as a REST server on which you can connect other devices to, for example, read a temperature sensor there, which is connected through SPI or wherever. You can even toggle some LEDs or read the status of a GPIO for a button, wherever you want. If you are familiar with the ASP.NET API style, you will feel at home there because it works using attributes on the methods. So you can come up with, for example, with the REST API in a very short time, and you can be very efficient coding that. We also have libraries for JSON, both to convert and to parse JSON. And what else? Connection to the cloud. MQTT, AMQP. We even have regular expressions. I would say 95% compatible with what you find on the full framework, which is very cool. We have another repository which is we call the community contributions, on which you can find several drivers and class libraries and utilities that were contributed by the community. On very soon, sometime the end of next month, May, you will be able to find to the IoT core bindings, which will be those 1 to 2/3 available also on as .NET Nano framework there. Okay, so to show how easy this is, I'll going to do a demo here with some very simple hello world. For this, I'm going to fire my Visual Studio. To make this work, the only thing that you need, besides one of the supported targets, of course, one of the boards that you'll find a list on our GitHub. You need to install the Visual Studio extension for .NET Nano Framework. And with that, you are good to go. All the rest is already there. Um, to create a project, you just go and find the project templates, and I'm going to to start here a simple Hello World application. Mhm. Okay, this is what you get on the blank application template. Um, right here, what you'll see, we have a window here, which we call the Device Explorer. I'm going to connect it here, and I have a board connected here. This is something worth noting. The connection to the target devices um, is simply an USB connection. Uh, yeah. Yes, I can. As soon as I start typing, I'll do that. um, when, as I was saying, the connection to the device is very simple. It's a simple COM port, a virtual COM port, and you can run you can have the full debugging experience that you are used to on Visual Studio without any fancy hardware, meaning that you don't need any JTAG adapter or anything like that. A plain simple serial port is all that you need. Okay, so right now, this is the simplest application that you can find here. What this will do, as you probably already guessed, it will output on the output window the yellow from nanoFramework. Right here, this is the device explorer. I can see here the device that I have connected. I can do here some stuff like pinging the device. This is useful to check if the device is responsible. This will show up here. And you can see here another thing that's interesting too is the device capabilities, on which it will output the capabilities of the device. I'm just going to scroll a little bit here. It will tell you everything about the device that you have connected regarding the build date and all that stuff. The native assemblies that it's supporting. It works with all this. The memory map for the devices, the RAM, flash, addresses, size, the sector map for the flash with the various storage blocks. It includes the nano booter, the CLR, and the deployment area, and also the configuration, which is used to store, of course, configurations. And this is the summary for the storage map. Okay, deployment map is empty because there is nothing deployed on the device there. Okay, so I'm going to zoom out here. Um, what this what we will do next, it's just basically hit the debug or the F5, and it will load the application on the microcontroller, and we'll start the debug session. I didn't put a breakpoint there, but I should have done it. But nevertheless, you can find here the the hello world coming from this line here, which is just writing a line, of course, on the debug console. Okay, so I'm going to stop this here, and we'll make it a bit more interesting by adding um, a NuGet package from GPIO and making some LEDs blinking. Oh, by the way, this is the what you see on the any regular C# project out there. You have your code and you have your references here, which come from the NuGet. And what I'm going to ask is probably framework, and I'm going to add the not the Windows devices GPIO, because this is the one it works too, but as we are moving to the IoT Core API, I'm going to find here the system device, which is not so popular, so it's a bit lower in the list. Okay, so this is a NuGet package, so there is not much to it. If you are familiar with this, you know how it works. So what I just did was to add a reference to the system device GPIO NuGet package, which brought into the runtime events, which are required to deal with events, of course. And what we'll do next is to add here some I'll find the GPIO controller here. Okay, and with this, I'm going to bring up an LED, for which I'm going to open a pin on the device that I have here connected, which is an STM32F769. The LED that I'm going to use, I know beforehand that it's on the GPIO 149, which sits on the port J 5. So it's doing the math, it will give you the 149 here. But we have a supporting library for the STM devices, on which you just need to put there the port number letter and the pin number, and it will compute the GPIO number for you. Okay, so being an LED that I want to blink, I want it to be an output. Okay, and right now I'm going to move this one below just to have something to put a breakpoint here and do something with it, and then I'll just do a while here, on which I'm going to toggle it, and then this I'm going to put what here, whatever. obviously this is not the one. Okay, and so this is it. To make it more interesting, I'm going to show you here the device that I have connected here. And now do something that I didn't do on the previous debug. Was to put a breakpoint here. So right now I have to make sure that I have this selected here, and then click on the debug or hit F5, wherever you choose or you like to, and it will do its thing. It just builds and uploads the application to the device. And here you have the breakpoint was hit because the application is started. Right now, if I'm starting to single step here, I'll move through this line, and you'll see the right line showing here. I'm going to zoom here. You see here the yellow, and next, as I go through this, it will light the LED. If I don't want to do the single step, I'll just hit the F5 and it will do its thing with sleeping those 250 milliseconds. It will be toggling the LED at any time. I can put a breakpoint here, and I can do this on a single step fashion. And run it free again. I can use the break button, and it will do the continue. And this is it. As you can see, I have here a simple Hello World application, which I did on just a couple of minutes by grabbing the NuGet package from NuGet and with just a handful of code lines. Okay, so I'm going back to the demo, to my PowerPoint. Okay, now I'm looking at the chat window again. Yes, on the AI, we don't have anything yet out of the box, but like I said, we are working on it, and it should be available pretty soon. If being an open source project and on the open source spirit, if this is something that it's appealing to any one of you, so feel free to join and start working on it, and maybe we can come up with a task force to have something interesting in a very short time. Who knows? Okay. As Mike was commenting here, the debugging experience is yeah, you're right. It's mind blowing, and it's second to none. You don't find this on any other platform, and with the Visual Studio IDE and all that it can do. I mean, from coding with all the cool stuff that includes from intelligence to the code analyzers and all that can make you really productive. And being C# the language that you know, it's very easy because everything on the MCU is abstracted. It's abstracted from you. You just need to plug the device and it's working. And you can even you can do something very interesting, and also which speaks of productivity. You can share code between your desktop or your server application and the code that you are going to run on the nano framework, which is awesome. And also the fact that you can run unit tests, which we'll see in a moment, it's also it's mind blowing and amazing. And the fact that you don't need any fancy hardware to do all this, and you are running code on the device, it's amazing. Something I didn't show you on the debug, but that you can do just like you do on any desktop application. When you are when you hit the breakpoint, you can look at the locals and the variables that you have there, and you can also change their values just like you do on the desktop. So this is something that you don't find on any of the equivalent platforms out there. All right. Moving forward with the presentation, um, we have the unit test framework. The unit test framework is uses the same framework that you are used to, which is provided by the Visual Studio Test framework. Um, and that you find on the full .NET projects. You have the classes which you decorate with the test attributes, and this we are using the ones from the Visual Studio Test, which have the similar ones if you are used to XUnit or any of the other test frameworks that's available out there. The principle is exactly the same. You decorate the methods and the classes, and you do the asserts and all that stuff, and then you go to test explorer, and it will do its thing. Um, you can run the tests on both the Win32 image of the nano CLR, which is included in the NuGet package, or you can run it directly on hardware if you want. So this is one step closer to have integration tests with for your devices and your applications, which is also something very cool, and it's that's not available on the other platforms which are equivalent to this one. So I'm going to do now. I'm going to show you the unit test framework in action. For this, and to so you don't have to see me coding all this, I'm just going to grab the I'm just going to grab the unit test sample that we have on our GitHub. Um, you'll see here you'll see here the class. I'm going to zoom in on this. Everything that you are used to. You have the attributes. You do whatever you have to do, and you do the asserts. Here, this one is testing types. This is testing the equalities. Right, this one about the nulls, empties. This is string comparison. And just like what happens on the full framework, you also have the setup and cleanup attributes in case you need to do something before the tests are actually run, and also the cleanup in case you need to do something to after the tests are run. Okay. So this is available too as a NuGet package. So you see here, I have the test framework here, which brings into the unit test launcher, which is the Win32 nano framework executable, which runs loads and runs the exact same assemblies that are loaded on the microcontroller. Okay. So just like you do with any other unit test project that you have, you run the build, and then you go to Test Explorer. I'm going to expand all this here. I'm going to run them, and they are all green. And to make this more interesting, I'm going to change something simple here. So, and I'll build again. And you guessed it. There will be one test which will fail. And I can see the detail on what is failing. Just like with the unit test framework that you are used to, it will tell you the message that it's here, and I can see additional output for this. It's basically telling me it's putting here the stack trace on the of the execution, so I can understand where this is coming from. So this is I'm sure you agree that this is very powerful, and it's something also mind-blowing, just like the debug experience that you find on the framework, on the nano framework. Okay, so this is basically what I had prepared for this presentation. So I'll go now and answer the new questions that are here on the chat window. Um, yes, you can use the because we have the interop feature. You can easily reuse C and C++ code that you have from any other SDK or libraries that you want. We have there's a blog post with detailed explanations on how to use that. Basically, what you have is an interface from your C++ code. So you build the image, including the C sharp code and the Visual Studio template. Create some stubs for you on which you expose the code beneath. You can pass values and objects to the from the C sharp code to the native code, and you can read back objects from the native code to the C sharp code. You can even fire events from native code, which will be picked up like any .NET event, for which you have, of course, an event handler, to do whatever you need with it. Um, Mike, MQTT support. Yes, we have a library for that, which is available as a NuGet package. Oh, okay, you're most welcome. Yeah, hopefully that's not too far away. Uh, Okay, Mike is asking another question about the hardware interrupts. Yes, if you have there the interrupt handlers on the native code, you can fire the events that will bubble up to your C sharp application. So you basically can mirror them from the native code to up to the C sharp application. There was another question here. Um, yes, about the .NET framework developed by Wildest Labs. Um, theirs is based on as far as I understood, on the Mono project, and requires a much powerful CPU to run, and they have their own module, and you have to run the framework there. Um, it's a totally different approach from the one that we follow. Like you've seen, we have a bunch of different targets and CPUs and vendors, so you can choose the one that you like most. You have the choice of using different RTOS, and basically you can accomplish the same. There's this closed source, ours is open source with all that it implies. So those are basically the difference. In the end, you can code in C sharp for small or not so small microcontrollers. Okay.